Welcome to Strategy Saturdays. My name is Ishan, and today we'll be discussing the ball screw. To help us out, we have Thomas from the build team. Welcome.
Thanks for having me.
So the first question we have is, what's a ball screw?
What's a ball screw? Right, so can you hold this right here?
Yeah.
This is a version of the ball screw. Right, so basically, in this simple model, basically, this part of the ball screw is called the ball screw. Right. This part right here is called the ball nut. You see how it's very smoothly spinning?
Mm-hmm.
The way that works is that inside there are a lot of ball bearings. And they kind of slide along these grooves, or the screw, basically. Mm-hmm. And so as this turns, it's very efficient because the ball bearings themselves, they're lubricated along with this so that it's very, very smooth. So the way it works is that not only this, but there are other components to the ball screw. The other components are to hold it in place wherever you're putting it, on our robot, right? For example, we have these things called pillow mounts. They're these very heavy black rectangular boxes that basically hold in place the two things, right? So they hold in place these, and then they also have a smaller axle from the ball screw itself that kind of extends outside. That is where we place something called an axle coupler. An axle coupler does exactly what it says. It couples axles. So it'll basically latch onto one axle of any size and latch onto another axle of any size. So our axle coupler, what it does is that it latches onto the ball screw and latches onto the motor shaft. So as the motor shaft spins, what do you think happens?
It's going to spin that, and that will transfer.
Exactly. So yeah, if you want to show the audience, you can put your hands here?
Yeah.
No, both hands. That's fine. So basically, as I spin this is getting shorter, that's getting longer. So which is proof that it's actually going to translate along this. So yeah.
So that's are there different models? Because that seems kind of thick.
Right, yeah. So this is really thick, and this is the version we used in our robot, which means that it's actually very, very heavy. Is it heavy?
Yeah, it's quite heavy.
It's pretty relatively heavy compared to the smaller models.
Mm-hmm.
This is what is, I think, diameter, it's around 16 millimeters, but for other ones you get 7 millimeters, maybe even 6 millimeters. They're different sizing. But basically, the smaller versions can turn just as well, but they might not be as efficient, and they will be lighter because it's less metal. So makes sense.
So you mentioned torque and the weight of the ball screw. So
yeah.
Are those some advantages and disadvantages that you can talk about?
Right. So the advantages to the ball screw itself would be it's very, very high torque, like I said, and it's also very efficient. It has 80 to 90% efficiency, which mechanical advantage, I think. But I mean that's very, very good for a part. So I mean those are very good advantages, but there are also some disadvantages. Like you said, actually, it's very heavy, and it will, because of the heaviness, it will cause balance problems for a robot. Now we put this on the left side of our robot, which means that if anyone hits us from the right side, then our robot might be able to tip over because it's very, very heavy. But another thing is that many of the viewers probably know this, but when you go for torque instead of speed, you're sacrificing speed, right? So if you have a very high torque, that means that your speed can be very low. But to compensate for this, many teams that do use this, or we've tried actually using this, is that we gear up our motor so that it can spin the ball screw faster. So, I mean, that may compensate for it. So, yeah.
So on your robot, I see that you guys have some touch sensors.
Right.
To stop the ball screw.
Yeah, right here and there, right? Mm-hmm. So basically, those touch sensors, as I was saying, another disadvantage actually, is that it's so powerful that it might break the robot if you mess up. Right. So if that happens, what we've done is that we have these touch sensors on the left and right side of the boundaries of the extreme. So the problem is that if the ball nut exceeds this boundary or that boundary, and it'll break outside the pillow mount, and it'll probably break the entire system. And all of a sudden, one of our main components doesn't work. So what we've done is we've basically locked this. That's the only way it basically translates. Mm-hmm. If we lock this in one axis. So if you lock this and then put something on top of it so that it will touch each sensor, then the sensor will know when it's on that boundary and will not allow the ball screw to move any further. Not only this, but we actually have, so we connect a motor radio, right, through our axle coupler. Mm-hmm. So not only do we have the touch sensors, that's our first gate, but we have a second gate so that the ball screw won't break our robot. And inside the motor itself, or actually outside, we put it outside. Depends on the motor. It could be Andy Mark or the normal DC motors that we have. But basically, those ones, what they do is they have encoders. And in our software team, our software team's great guys, what they do is that they basically say if it goes past the encoder limit, then they don't allow any more motion in that what's called plane. So
you
it
have
won't be able to translate.
two safeties.
Right, two safeties, which is actually very smart. Really good job to our software.
Yeah.
So, yeah.
Alright, so now we have the ball screw, but are there any alternatives to
Alternatives, right. I'm very glad you mentioned that actually. So the ball screw works for actively changing, like translating something across the robot. Now, I brought something here, just in case you asked something like that, actually. But basically, it's something called a linear slide. Now, what do you think the difference is between this and the ball screw?
Well, the ball screw has to rotate on a screw, right? That's
Right.
just sliding across.
Exactly. Right. So there's no axial motion. The ball screw is axial motion from the motor being translated into translational motion. With this, it's like this is kind of a rail. It's like a linear rail sliding thing, right? And not really technical, but whatever. So basically, it slides among this, and you need a motor to move this across, right? Now, fun fact about this is that you know how that one uses ball bearings.
Yeah.
This actually on the inside, can you see that?
Yeah.
Right, it has small ball bearings so that, and it's also pre-lubricated as well, so that it will be very smooth. But this is mainly for like, what's it called, using a motor to drive something across, and not only that, but it can kind of move like that. So you probably have to lock it down in maybe 1 or 2 degrees of freedom. This one is for torque. This is
Okay.
for torque.
So you've given us examples and shown us alternatives.
Right.
How did you guys use it in your robot last year?
Yeah, so that's really like the meat of this entire thing. That's really good. So basically, the ball screw, we attached it right here, as I said. And so basically, as the motor turns, then this shifts the ball nut. And as we said, we have the sensors and coders, right? So I'm going to give you this. It's called a potentiometer. So can you attach that right there for me?
Yeah.
Right. So basically what this does is that it simulates us not having to, let's call it, turn on the entire system, but so we can test one motor. Can you turn this on?
Yeah.
Right. Right, so as you turn that on, you can see that the ball nut slowly goes to the right as it translates, which means that it shifts the angle. So we can basically change the angle. Can you go the other way? Right, so now you're going the other way so that it will make the angle like this. Right, can you turn it off for a second? Yeah. Right, so I'm just going to take that out actually. Yeah. Right, thank you. So what we used this for was getting the specific angle for having our robot being able to climb up the cliff, right? Or actually climb up the ramp in some cases, because there were churros on the ramp, and so our robot could grab onto those and pull itself up. So we used this specifically because, again, pulling up our gigantic robot, I think it was like 30, 35 pounds by the end of it, because the ball screw is actually very heavy, and the pieces that it uses to attach itself to the robot are very heavy. Heavier the robot, the bigger the robot, right? And not only that, but if you're lifting a really heavy load, then you need a lot of torque, which is why we use it. Yeah.
So this was in the FTC game Rescue.
Rescue,
right?
exactly, because that's when one of the main missions or main thing everyone was trying to do was trying to get to the cliff.
So when I watched some of your games, I saw that at one point you guys used the ball screw and the arm to actually put yourself back up after you fell over.
Yeah, we did. Right, so that's actually when we did that, it was like amazing. All the refs were like, holy crap, wow. But a lot of it was kind of like an innovative thing that our drivers kind of like came up with on the spot. With the ball screw, it just gives you a lot of things you can do, but you don't really realize those things until, like the heat of the moment, right? So what our drivers did, which was really smart, was that our robot kind of tipped over. In robot competitions, it's really rough, right? So robots get like hit all the time. So our robot kind of like fell over, and what our drivers did, really smart, is what they basically translated the ball nut all the way to the end, and because it was already on like this, it was like this, right?
Yeah.
They basically took the arm angle and basically changed it so that it would literally lift up the robot, which was really, really cool. Seriously.
That just shows the sheer amount of torque and power it has.
I know, and not only that, but like so many applications for the ball screw itself.
So now, if I were to want to buy one of these,
right,
what would be the price?
Yeah. So, I mean that is another what's it called disadvantage, right? So I mean this gives you so much like what's it called leeway in whatever you really want to do with it, but the main problem is that simple ball screw and ball nut, with all the ball bearings inside, obviously, cost about $35 to $50.
Wow.
$35 to $50. Which, I mean, for some teams that might be a lot. If you get a lot of sponsors and a lot of money, then it may not be a lot for you. So then this might be an option. But with the entire entire system with the two end supports and the axle coupler, not the motor, obviously. But with all of that and the ball screw and the ball nut, that's about $117, which means it's like, this should only be used, like, ideally, if you want this for very, very high torque scenarios. If it's not for very high torque, then it's overkill.
So I'm guessing that this comes in smaller models, so that would lower the price.
Right. Like we were talking about it earlier, actually.
Yeah.
Right. So this, as I was saying, it looks very thick. That's because it is 16 mm across, millimeters. If you go for smaller ones, then not only will they be lighter and they'll probably be they'll probably balance out your robot more, but it will also be cheaper and they'll be thinner as well. But you might not get the same efficiency as we got from ours. This was made by, I think, a company called Tenhai, right? And so they produce a lot of ball screw components and a lot of other mechanical components. So you guys should probably check it out. So, yeah.
Alright, well, that's all we have for you guys today. Thank you for being on the show, Thomas.
Thanks.
And we will see you next time. To recap what we've learned today, the ball screw converts axial motion into linear motion. It does that through the use of the ball screw and the ball nut, which is held in place with two pillow mounts on both sides and an axle coupler that connects it to the motor. This allows it to have a high amount of torque, but at the loss of speed. These come in varying sizes and have varying ranges of price. Thank you for tuning in. We'll see you next time on Strategy Set Your Days.